quadrant 2. And so it makes sense that tangent's negative, right? Okay, so far I haven't asked a question. I just told you I'm in quadrant 2. Whatever the hell the angle is, tangent comes out to be negative 2/5. Okay, and then I ask you, what is sine theta? So what do? Something you have to let go of is this. If I just tell you that, can you draw the triangle? This just tells me what SIGN, if it's going to be positive or negative. What's sign going to be in this quadrant? Positive. So that's all that's there for. I think once I put that information, everybody kind of thinks it's different. But if I ever tell you this, you can draw a triangle, yes? And if you draw a triangle where this is true, you can figure out what sign it is, right? So what do I know from this statement? What kind of triangle can I draw? And if you want to be really specific, yes, a right triangle. Thank you all. That's perfectly right. And then why does this negative make sense if I draw it like this? Yeah, because this negative 2/5, so what's the 2? It's the y side. I kind of gave it away because I was like sitting here. And then this could be negative 5, because that makes sense, because the x is negative back there. Okay. So that's why tangent, keep stepping on myself. Tangent theta is negative 2/5. Let me stop for a minute. Is everybody with me? That explains why that part is negative. We all understand that's not really like necessarily a physical triangle because there's a side that's negative. It's just because it goes back on the x-axis. What am I missing to figure out sine? Huh? Yeah. He's going to help me figure out what I'm missing. I'm missing that last side. Old Greek dude. Whoops. Actually, his followers that he stole from, but it's okay. They all died. It's okay. And I'm like, yeah, Jeff, they were from long ago. Okay. Yeah, just missing the hypotenuse, do Pythagorean. So basically, you do the same thing with what I gave you. Is that better? Except for that one, you're in what quadrant for the one from the test?
2, 3.
Yeah, you're in quadrant 3, right? Because it's, if I remember correctly, isn't it, I gotta look it up.
It's negative 3/7.
No, but pi, theta is between pi and 3π/2. That is between the x-axis back here, that's pi, 3π, that's the third quadrant, yes? Okay. All that part helps you with is the answer going to be positive or negative. Okay. Anything else from anything? Doesn't have to be from the test. Kelvin just had some questions for the test. Okay. You guys doing all right? Aubrey's back. Did everybody notice? She made it? But like she said, she's not the one in trouble, we are. All right. If you don't know what I'm talking about, it's probably better. Okay. So here's my plan. I originally thought I should have a quiz on tomorrow. Sorry.
Wow. On tomorrow.
And because the review for the final schedule for Monday and Tuesday, I don't necessarily see a big reason to have a quiz. Although, from a student perspective, you guys should want more grades. However, I'm almost certain if I put it to a vote, the vote would go, let's not. Is that true?
Yes.
Yeah.
Okay. So here's the plan. What we're going to do tonight, we're going to cover trig equations. Yes? That's the last new thing. Right? And let's see how far we make it. There is a problem on, actually let's do this. Let's take a step back. Does everybody still have the handout from last time? I have extras here somewhere, I just gotta find them. just add that again. Here, there. Is that it? No. Here we go. Okay. No, I don't have extras. I have one. Yeah. Okay. Does everybody have this? It was just this. If you don't, I'm not sure what to do for you because does everybody have this? Okay. So we did a smattering of these. So let's do this. Let's do C and D together. And then I'm going to have you guys explore this. I don't know why I put sign up there. Oh, I'll be on. So let's look at part C real quick. Hopefully, so this is good. So it sounds like most of you guys were here last time. I know we were missing a few people. Well, all right. Part C is a little gross. What do you guys, does anyone notice anything about part C? Let's see how much you guys remembered about what I said last night. Okay, good. So one thing you should immediately realize is there's a third power, and that's a little bit tricky.
Yeah.
Yes? Because what you're normally looking for is squares. What else is weird? Look at the angles.
There is no.
What's that?
Most of them in it have an angle of x. Do you guys see that?
Some of them don't.
One has an angle of 2x. One has an angle of 3x. Does everybody understand what I mean when I say what I just said? What is inside the cubed cosine? An x. That's the angle. Everything's got an x except this guy's got a 2x. That's the angle. His angle is 2x. So this guy's angle is 11. That guy's angle is 22. This crazy dude over here has got a 3x. Now why is that trippy?
We haven't touched it before.
We don't have a triple angle formula. We have a double angle formula, right? We also have a sum of angles formula. Okay. The angles not being the same is the first level I would say you should notice. The cube you can notice because that's weird because we're used to looking for squares. Oh, there's a cubes there. We're like, oh. All right. Whenever I'm trying to show that these are true, this equation is true, this identity is real, they have to be referencing the same angle for me to show that they're equivalent. So, what can anyone see anything you do with one side or the other? So when you're doing this as a student, part of this is just, do you see something to try on one side? If so, try it. See if it takes you anywhere.
We can write out the cosine of 3x.
Okay, good. What would I use?
The cosine thing powers. The product is sum. No, yeah. Yeah,
Oh, are you looking below the black line?
yeah.
This will be an above the black line situation.
Well, the sum of difference.
By the way, here's a really huge clue. Okay. What is 3x if you had to add two angles? Because we know what cosine of a plus b is, don't we? We know a formula for cosine of a plus b. Yes? I'm not saying you have it memorized. I'm just saying we know it.
1x.
So what is cosine of 3x made of? Cosine of x plus 1. We don't have a formula for 3 angles added. I have a formula for 2 angles. Cosine of a plus b. You see what I mean? There's no cosine of a plus b plus c.
Yes.
Not that you know.
X plus 2x.
X plus 2x. Does anyone see anything interesting if I rewrite that one side in terms of x and 2x? What's the other side in terms of
X and 2x.
x and frickin' 2x? Yes? Do you start to understand how to look at this? The angles not being the same is an immediate concern. 3x is the trippiest angle up there. So I'm like, oh, 3x is x plus 2x, and I have a cosine sum formula, and the other side is all about x and 2x. Holy shit, it's starting to come together. Yes?
Can we write it out? I need the visual.
No, we are. I just had to stand here for a minute. And then I'm going to go over there. Sorry. So cosine of 3x. So I'm going to work with this side. Cosine 3x is cosine of x plus 2x. Now, can somebody help me rewrite cosine of x plus 2x?
Cosine of x, what's cosine of x? Or yeah, that one. Minus sine of x, minus sine.
Not minus.
I mean, two x.
Cosine x times cosine 2x minus sine x times sine 2x, yes. Cosine minus sine. Cosine is an asshole, so it's him first, and he makes the plus become a minus. Yeah.
So wait. Cosine, the cosine 3x equals that bottom one?
Yes. Because we wrote it in terms of cosine of the sum of two angles, and we have an identity for cosine of the sum of two angles. Okay. Do you see anything that's related to, are we closer to this side now? Let me just say it like that. What do you see at the very end of what we wrote? The very end of what we wrote.
Oh, you already did it.
I see a sine 2x. We're getting close, right? Already. We ain't there yet. Damn it. Now, real quick. Here's the cool thing about, I have no idea why I did that. Okay. Okay. Can you all see what I'm saying? Can you identify the parts that, in fact, don't we have this entire last thing is right there, yes? We're on the right track. We're doing good, guys. We're having a good time. What's different here?
Sine x cosine 2x.
What's here that isn't there?
The two x.
Yeah, the cosine 2x. Yes? Okay, so.
But now we can rewrite.
Go ahead.
We can rewrite it again.
Shit, yeah. All right, but what's more important, I'm never going to give you this problem. Do you understand? I'm never going to give you this problem because we're already doing it. It don't mean shit anymore. What's important whenever we do a specific problem is what motivated me to do what I did. You guys with me? That's what's important because I'm not going to give you this problem. Yes? This is here. This is not. This especially is wrong. So I'm going to focus all my attention on him. What sucks about this guy? It's cosine, so he's an asshole. But what's especially asshole-ish about cosine of 2x? How many ways is there to rewrite it? 3. Do you see how I have 1 cosine right here? Do you see how I have 3 up there? Which way to rewrite cosine 2x would end up with me getting 3 cosines?
The first one.
Yes. So if I take, and again, if you don't see it, just try all 3 of them. Just try to shove. Do you guys see the 3 options? Does everybody see the 3 options? Everybody's got that green trig law sheet from last time, yes? Hopefully nobody's being weirdly polite and not saying anything. Everybody's got that sheet, yes? Okay. Do you all see how to read the cosine 2x? There's 3 options. You could put each of them here until you get one that works. There's not a damn thing wrong with that. You understand? In fact, that's what I told you. That's part of the process. To pick the wrong thing, go, well, that was the wrong thing, and then pick something else. What you guys just noticed is, if I use that first way, where did this come from?
That came from cosine 2x.
I just rewrote cosine 2x. That's what it is. Yes? And I still got this stuff at the end. Now what can I do with this cosine x? Distributor. Well, how many cosines do I get there?
3
Kick ass. And then this times this. Is that what's up there? So you go, wee-haw, chabow. Right? The trick with these is it ain't gonna look like the other side for a while. You're gonna do stuff, and you're like, please begin to look like the other side. So don't automatically discount what you're trying. Keep going. Keep simplifying, because maybe something happens and it starts to look like the other side. Okay. This is one of the more frustrating things, and I understand. because there's no like prescribed way to ever do it. There are general things. Are the angles the same? Focus on that. Are there two fractions on one side and not the other side? Get those together. You know, there's general things to try. But there's no like, always do this when you do it. Always do, no, it's none of that shit. It's just play. This is what I used to say all the time, and I don't know why I've stopped. This is where you first learn to play with shit. You're playing with math, right? Like, it doesn't feel like it. But that's what we're doing. We're just trying stuff out, seeing what happens, what works. Okay. Look at this guy. Can you guys remind me, just this piece, just the inverse tangent of 3/4? Can anyone please tell me, geometrically, what is that? That's a weird question.
4/3.
No, none of that says reciprocate. That's the inverse tangent.
Right.
No, it means that the input is the ratio, and so your output's an equal.
So the inverse tangent of 3/4 is an angle. That's what it is geometrically. Ding, 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 ding. So this says sine of twice an angle. Do you guys see that? The inverse tangent is an angle. Because it takes what normally goes inside of a trig function and makes it the output. An angle goes in, so an angle comes out of an inverse trig. So this is sine of twice theta.
Yes. Double input.
Because here's the thing. Can you guys draw the triangle that goes with this? Do you guys remember doing that? Like if that 2 wasn't there, we still need to do this, but let me show you. There's a little bit of a trick here. Can you guys draw the triangle that this relates to?
Mm-hmm.
So here's the angle. We know the ratio, and we know it's tangent. So where's 3 go? Yeah. And where's 4 go? Does anyone remember this triangle? 3, 4. No. 3, 4, I had to lay them flat, and then I don't get, if I make it 7. We don't need a root do for 3, 4, 5. Or if you do, it's okay. Now, if the question was, what is the sine of theta? The answer is 3/5. I'm done. Is that the question?
So 2 times.
Yeah. I don't know shit about twice theta. Do I know shit about twice theta? I don't know shit about twice theta. Do you guys see what I'm saying? I know everything about theta. You ask me a question about theta, I'm done. I see it all right there. I don't know shit about twice theta. Do I have a way to rewrite sine of twice theta so that it's using theta? Because I have a triangle with theta in it. Do you guys see what I'm saying? Of course we have a way to, what's the way to rewrite sine of twice theta? 2 sine theta cosine theta. I already gave this away, but can somebody say what sine theta is? What's sine theta? Here's theta. What's sine theta? 3/5. What's cosine theta? 4/5. Yes? 2 times 3 times 4. 5 times 5. Done. Trippy shit! But it's the double angle formula sort of hidden. Because we don't, I don't blame you if you don't automatically look at an an inverse tangent and think angle. You need to. Inverse trig functions are angles. Okay, I like it. How we doing? Now, is there any questions from that? All right, okay, so the next part of this class is interactive, thank the gods. It's too bad. Some of you guys are like, it don't have to be. Yes, it is. I'm going to change this so it's the same as the one on the paper. Can anyone come up and give me one answer to that?
I can do it.
Let me give you,
Do I have to write? Write it down?
yes. Oh, you got it, okay.
Do I have to show word?
No,
Okay.
you should not have to show word.
Okay. Is that right?
There. Does everybody agree?
Yep.
Kick ass. Thank you, Rich. You are safe. You It will not be voted off the alley. Can anybody else give me another answer? Is that the only answer? Bless you. Is that the only answer?
No.
Can somebody else give me another answer? Come on in. Get up here.
300.
Right now. All right, cool. Is that the only two answers?
Yes.
Just keep rotating.
What do you guys think? Can somebody give me another answer? Why? Can somebody give me one more answer? Go. Ooh. Well, you're the only one right now that's getting up, so you got bonus points for that. So let's talk about that one for a second. Where does negative 300 end up? Reference angle of what? Don't worry, Joe. You're good. Where's negative 300 end up? What would the reference angle be? It doesn't quite get all the way around. How short? 60. And isn't 60 an answer?
Yeah.
So of course that's an answer. Yes? Because that's the same stupid angle, yes? So these two angles are not related by that, are they? They are the two places where cosine is 1/2. If I'm only thinking 0 to 2 pi, 0 to 360, yes? It's either in quadrant 1 or it's in quadrant 4, yes? Because then the x piece is positive. Are you guys with me? And that's why it's positive 1/2. Is everybody really with me? Kelvin said, all right, let me take 60 and kind of go back. I'm not really sure how you thought of negative 300 necessarily. Is that sort of how you did it?
I just subtracted 360.
Totally. So you started with 60 and you subtracted 360.
Yeah.
So couldn't you start with 300 and subtract 360? Where would you end up? What's 300 minus 360? Negative 60, which would be here again, yes? Which is coterminal with that angle, yes? Okay, maybe. Could I do another 360? Could I not just keep doing? So like I could take 300 and I could add 7 360s to it, yes? And I'd end up in the same dumb place, correct? But it's still officially a different answer. Yes? Because remember that parking lot thing I told you about? Where even though the angle is the same, I'm going up as I go around. So it's still the same angle, but it's a different height. So even though these all end up at the same place, that's us looking from above. But look from the side, it might be a totally different place. You guys, so it always bugged me that it's like, oh, it's a whole different. I'm like, it's not a different. You turn around 8 times, the same way. So why even turn around? But if I'm like, oh yeah, there could be a third dimension where I am actually gaining height as I turn, that makes more sense to me. So, Jeff, what the shit did you do this for? Was that 2820? Does that sound good, kids? So that sounds right.
7 times 360.
Plus 300.
2520.
2520?
Yep.
Plus 300. Did you add 300?
Oh, no.
Yeah, 28, 20.
Sorry, it's my one skill.
Right.
Not the dancing, that's obviously not skill. All right. So the point here is, real quick. Do you guys, I don't even know, does everybody understand these two answers? Really, does everybody really understand those two answers? We've been building up to this. Because if you know cosine of 60 degrees is 1/2, if I say cosine x is 1/2, 60. The next level is to go, that's not the only place. 300 also. Then the next level beyond that is, I could add, subtract however many rotations from either of those. So I could start here and go forward or backward at however many rotations. Oh my god. I think it's Mark.
He's gotten into the classroom.
It's been a good life. The door's gonna open and someone Mark's gonna crawl in. I'm here for Jeff. Okay.
Except at night, but I don't know.
That was exciting. Is everybody kind of with me? And I just realized, whoever's at home, you didn't see any of this. There, see it? Okay. Okay, so let me put it up here on the overhead. So what I always hate about the way trig equations are introduced is people jump into the full-blown equation. We've been... Oh, Braden's losing his support. Nobody bully Braden, okay. We've been getting ready for this whole time. So we have 60 degrees, we have 300 degrees. Let me write this. I'm going to write this in degrees this one time. I can add and subtract. How much? 360. How many times can I do that? So you ready for this? I can add and subtract any multiple of 360. Where k is like 1, 2, 3. Could I add 360 once and end up in a good place? Could I add 360 twice and end up in a good place? Can I add 360 3 times? Wouldn't that just be k 1, 2, 3?
Yeah.
Could I do it 4 times? Could I do it 5? Could I do it 6 times? Maybe stop doing that. Okay. So k just represents any multiple of rotations, yes? Do you guys get that idea? I need you to get that idea. If I know this angle is an answer, then of course 360 forward is the same position, it's the same, it's an answer again, it's gotta be. And I know 360 backward. That's why I got plus or minus. How many times can I rotate and end up in the same place? Infinite times, man. So I just put a k there and I'm like, you make k whatever you want to, leave me alone. Make k 11 if you want to. You guys get that? If one angle makes the equation work, there's actually an infinite number of angles, because there's an infinite number of angles that end up in the same place. And it's where they are that tells me what the value is. Yes? And if there's an infinite number of things that end up here, there's an infinite number of answers that make it 1/2. What would this look like in radians, which is the language you have to continue to get used to? Yeah, so in radians this would be, Jeff. In radians this would be pi over 3 plus or minus 2 pi. Okay. Okay. And this would be, what would this be? No? You could do it. What's all the way around? 2 pi. How many thirds is that? This is 6 pi over 3. 1/3 of a pi before that is, like Braden said, 5 pi over 3. So officially, how many answers does that equation have? Bless you.
Sorry,
Infinite number. Braden's like, technically I'm right. It's got 4 answers.
I just looked at the thing up there, said 4.
It's got 4 parts. Is everybody, you guys... This is very trippy for some students, but it's the thing we've learned from the beginning. Coterminal angles. If this angle makes something happen, then 360 later, the same stupid thing happens. So of course, if I need it to be 1/2, there's an infinite number of places where that happens. But there are these idea of base angles. The base angles are the one between 0 and 2 pi, and they're the ones that I add and subtract from. Yes?
Did you mean to write cosine instead of sine?
Yeah, that's been bugging me the whole time. On the paper, you wrote sin x.
Oh,
1/2.
I'm sorry. I don't know why I keep doing that. Because I had that on the board first, too.
That is true.
Yeah. Good job, Jeff. Okay. How does everybody feel about the basic idea of that? Let's do one more. Oh, let me ask you this before I forget. So real quick, this is the answer. X equals this, X equals that, yes? What would the answer be if I do this? I know this is dumb. On one level, this has to be desperately dumb, and I don't care. What is the answer if my equation is cosine A equals 1/2?
It'd be this thing that
A equals that shit, yes?
Uh-huh.
You with me? Stay with me, there's a point to this.
I don't like this. Okay.
We're gonna go A.
What do you mean you don't like it?
It's setting up for something bad.
No, it's nothing bad at all.
No, there's feelings like that.
That would be the same thing, yes? It would just be A equals blah, 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 yes?
Yeah.
What if instead I said cosine beta equals 1/2?
Beta equals blah, blah, blah.
Beta would equal beta. You with me?
Yeah.
You with me? So here's what I'm setting you up for. I love you guys. So if I have cosine of 2 theta equals 1/2, here's where people overthink this. Did you care what I call this angle? I could call the angle x, correct? Did that change what it was equal to? Compared to A? No. Compared to beta? No. So can anyone tell me what 2 theta is?
Blah, blah, blah. This stuff up there.
Blah, blah, blah. So it'll be pi over 3 plus or minus 2 pi k. And 2 theta equals 5 pi over 3 plus or minus 2 pi k. Is everybody honestly cool with that?
Yeah.
If I could just write, it would be amazing.
It still equals the same thing.
I need you to be cool with that. I don't care what I call the stupid angle. Cosine of angle equals 1/2. The angle is these 2 things, yes? We know it's infinite, but these 2 expressions, yes? Can you solve for theta? Because that's the thing I'm asking for, right? This one has an extra step. Because it's not just some arbitrary angle, it's twice an angle. But I first solve for 2 theta. How do I get theta by itself?
Divide by 2.
Divide by frickin' 2, right?
And it's just
What if I had a 3 there?
divide by 2.
What if I had a theta over 2? Multiply by, okay, do you guys see? So it always makes people think you have to use an identity on this shit. Dude, don't use an identity on this shit. You could if you want, don't. Even if you want to, don't. Because that's relatively easy. And all I have to do now, I'm not done. I know I'm done when I get variable equals stuff. I don't have that yet. I have twice variable equals stuff. So if I divide the first one by 2, don't freak out here. Cut it in thirds, cut it in half. How many parts did I cut it into? Cut it in thirds,
Oh, 6.
cut all that in half, cut it in sixths. Yes?
Yeah.
And of course, what's this? Pi k. And then this one, divide by 2. 5 pi's cut in thirds, cut in half, so it'll be 5 pi over 6. 2's cancel again. Something I want to point out. What's the period of cosine? 2 pi.
2 pi, yeah.
What happens to the period here? Do you remember? To get the new period, what do I do?
You divide.
Take the old period,
You divide by
divide it by 2. What do you get?
pi.
You get pi. That it makes sense. Pi is how often it comes back to the same answer. That's why up here it was 2 pi. Down here it's pi. Do you have to think that way at all? No. Okay, let me stop for a minute. So if on the first one I had just said, find all the solutions from 0 to 2 pi, you would have stopped there. You guys with me? If I said find all the solutions, period, you better give me infinite number of solutions. How are we feeling?
Slightly green.
Okay. On the tails of that queasy feeling, I want you guys to do this. Oh, Maria. Maria's like, quit, let me do something.
Maria said when at a board she's stuck at candy can or whatever that is.
You know what? Okay.
Just wanna try and do it. You may not record any of this class then, to be honest.
No.
So I don't-
Good thing you're here.
Jeff's face on it. Yeah.
What was it? Last semester there was a thumbnail with the face like right up on it. I had done something in the middle of class and it just chose that
That's
image.
hilarious. Should we try to read or something?
No.
Too bad. Technically,
Corinne, how you doing?
I kind of skipped over that one, but I tried doing this one using this one. I don't know. It can't be easier,
see,
but
this
I don't
is
know.
a triple. So,
Or-
we did one like this earlier, so, cosine of what is 1 half?
60, right?
Yes,
wait,
so pi over 3,
yeah.
right? That's what I was gonna say, like, really? So then, you know then that, and now you gotta think about what other quadrant it would work in. But then you know that this equals pi over 3.
Mm-hmm.
That's one answer, right?
Sure.
Now what's the other answer? Now you think about the other quadrant. So pretend like the 3's not there. 3x is just the name of an angle.
Mm-hmm.
So you're gonna solve for 3x. Don't try to do shit with the 3. You don't have to. We did an example earlier with 2 and then we divided by 2 at the end. Here you're gonna do 3x and you're gonna divide by 3 at the end. You don't have to rewrite it from the beginning. Solve for 3x. So you already know, you just told me 3x could be pi over 3.
Okay.
If 3x was pi over 3, this is cosine of pi over 3, which is 1 half.
Mm-hmm.
Yes? So 3x could be pi over 3. Then you can do the plus or minus thing.
Plus or minus, I mean, from before?
The 2 pi k, yes. Because
Okay.
now I want all answers.
Mm-hmm.
Or, so you can write down 3x equals pi over 3 plus or minus 2 pi k.
Mm-hmm.
Or 3x equals what other? So now you need a reference angle of 60 degrees, pi over 3.
Mm-hmm.
What other quadrant is cosine positive in? Your
Cosine's
perspective.
positive?
So I want the x to be positive.
3? No, positive. 4?
4.
Okay.
So what has a reference angle of pi over 3 down here?
Um,
So this is 2 pi, yeah? It's just 2 pi? And I want to take away pi over 3? Yes?
mm-hmm.
So 2 pi is 6 pi over 3, is that cool?
Please bear with
6 divided by 3 is 2, so it's 2 pi is 6 pi over 3. Take away pi over 3. 6 pi over 3? Minus 1 pi over 3. 5 pi over 3. So 3x equals 5 pi over 3 plus or minus 2 pi k. Then the last step is divide by 3 to solve for x. So don't try to take care of the 3 at the beginning, take care of the 3 at the end.
Okay.
Yeah. What? Oh, okay. Oh, okay. I don't blame you. So can you tell me, like, what is sine of pi over 4? I don't mean to put pressure on you. Do you remember? No, this is radians, but I just want to know what the answer is like. What's sine of 30 degrees? Let's start there, which would be pi over 6. Well, what's sine of 30 degrees? Good. What's sine of 60 degrees? Yeah, so what's sine of 45, which is sine of pi over 4? Yes. What's cosine of pi over 4? That's the one place where they are equal. Yeah. So this is also. So what's tangent of pi over 4? If tangent is sine of cosine, they're the same. What's tangent? If I take what this is, divided by what this is.
I just wanna see, I already.
So tangent is 1 when I have some over 4 radian. Every time it's an over, like 11 pi over 4, 3 pi over 4, 7 pi over 4.
That's what I did, I divided.
Tangent's gonna be 1 or negative 1. It's 1 in certain quadrants, it's negative 1 in other ones, yes? Okay. So the first thing is to realize, this has gotta be some kind of pi over 4,
Yes,
or
yes.
something.
Yes.
Now what quadrants is tangent
Yeah,
negative?
Cosine is only positive and.
Tangent's negative if sine and cosine are different signs.
Huh?
Yes? So where are sine and cosine different signs? Where are x and y different signs?
Let me go look. I'm pretty sure this.
First question. Yeah. 2 and 4.
Oh, wait, no.
Total. So now I need a pi over 4 reference angle in quadrant 2 and quadrant 4, right? Oops, this one. Quadrant 2, weird this again. Quadrant 2 and quadrant 4, yes? Okay. So now just, can you think about,
Yeah, that's what
if you go pi over 4 from pi, from 180 degrees, right?
Oh, yeah.
What angle is that?
I just didn't do
If you
this.
go pi over 4
Yeah, we did that.
back from 2 pi, what angle is that? Wow.
I'm judging you, and I'm fighting you one thing.
Why am I being judged?
I didn't feel like writing it anymore.
Hmm?
I was gonna write it, and then I was like, nah.
Is it in any relation to?
That's right. But I mean, I'm gonna make a mistake on purpose and show you how it leads to the same answer.
It's in relation to what we did at the beginning of the class.
I mean, yes. No. Why did you just have 120? When is tangent 1?
Technically,
Tangent's 1 when
First
sine and
answer
cosine
includes the
are
second answer, so.
equal. When are sine and cosine equal?
45.
Ah, okay.
You remind me of my younger brother. Technically.
Well, technically.
Actually.
Well, if you look at it like this.
Well, then don't look at it like that.
So this is hydrogen
Alright.
and.
So let's take a look, guys. There's several layers to being able to do this. This equation gives us 2 pieces of information. Tangent is negative. Alright, let's stop right there. When is tangent negative? 2 and 4 because tangents made of sine and cosine. So they have to be different signs. They're different signs in the second and fourth quadrant. That is one piece of information that I need. So I know that the answer exists in the second and the fourth quadrant. Yes? Second piece of information is that tangent is supposed to be 1. I'm ignoring the negative for a second because I've already got that part figured out. When is tangent 1? Yeah, when sine and cosine are the same, which is at 45 degrees, which makes sense because it goes from where they're both the biggest, they both start shrinking, and then they both equal each other halfway, which is 45 degrees. So it's going to be some kind of over 4. So pi over 4 is our referencing. I desperately need you to put this together. Reference angle is always how far from the x-axis I am, and I know what quadrants I want to be in. So I know this little angle here is pi over 4, which means what is the actual angle then? Sure. No, 145. 135 is right, but it's just not. It's not right because I'm in radians. What's 1/4 of pi short of a pi?
Oh, 3 pi.
You guys see how to look at this? This is a full pi, yes, and I am 1/4 of a pi short, which sounds like something my grandma would say about me. That boy is 1/4 of a pi short of a pi. So where was young Jeff in terms of his mental acuity on the scale of pi?
Not quite there.
Not quite there. He was 3 pi over 4 according to Granny, yes?
Yeah.
Of course, she thought that dinosaurs didn't exist and they just put the bones together wrong, which is hilarious. But we'll stop talking about Granny. She's not around so often. So this is also pi over 4, but that's shy of 2 pi. Yes?
Just so I remember correctly, the tangent of the angle in question, 3 pi over 4, is going to be the same as the tangent of its reference angle, pi over 4.
Exactly.
Because they end up in the same spot.
Yep.
Which is why this works.
Yeah.
Okay.
Yes, good.
I
And
just want to be sure. that,
no,
like,
this is something that's been behind the whole thing this whole time, right? I hope I said something like that. That's the whole idea. That's why we look at reference angles. That's why we only have to memorize first quadrant. Because I don't care what quadrant, man, it just matters on the first, the reference angle. The reference angle is always related to the first quadrant. Because you can't get more than 90 degrees away from the x-axis. You guys agree with what I just said? If you think you can, So I'm 90 degrees. If I go a little further, oh shit, now I'm closer than 90 to the x-axis. So the reference angle is always between 0 and 90, so it's always in the first quadrant. That's all we only had to memorize first quadrant shit, because it just repeats. So what's the other angle? Yeah, because it's 2 pi minus pi over 4. 2 pi is 8 pi over 4 minus pi over 4 is 7 pi over 4. Okay, so my two angles, my two base angles are 3 pi over 4 and 7 pi over 4. I'm going to make a mistake. I'm going to make a mistake different than what somebody else did. I'm going to do this. This is an understandable mistake. If you make this mistake, I'm not going to get upset. But it should be semi-obvious why this is a mistake. Tangents period is what? Pi. Let's see if I can just. This is so important. Remember earlier when we got the answers were I can't remember now. Pi over 3 and 5 pi over 3, yes?
Yeah.
Remember that? Can I, now, this is going to be a little tricky. Can I go the same distance from here to here and the same distance from here to here? Can I take the same size step to start at one answer, pick up the other answer, and get back and get the next answer? Or is one of these steps bigger than the other? You guys see that? Do you guys see that? Do you guys see that? That's why I needed two statements to capture all the answers. Now look at our current. Can somebody tell me how far apart pi over 4 and 7 pi over 4 are? Huh? I'm sorry, 3 pi over 4 and 7 pi over 4 are 4 pi over 4 pi apart, correct? So let me see if you guys are really, you're ready.
All right.
I can start from one answer. If I go pi, I get the other answer. If I go pi again, I get the next answer. If I go pi again, I get the next answer. I don't miss anybody. If you write this, I technically can't say it's wrong. It's just writing too much. Because I can start at 3 pi over 4 and I can get every frickin' answer if I just do this. Now, the fact that the period of tangent is pi should have told you that there's a better way to write it, that instead of 2 pi, right? It doesn't have to be in reference to 2 pi. But at this stage, we're not going to live with this very long. There's ain't much time left of the damn semester. So if you put the first part answer, I'm cool. I'll just,
Mark it wrong.
sure. No. Just the second part is a little more right. Yeah.
Why again is tangents period pi and not 2 pi?
Because that's how long it takes it to get done with the cycle. Let me think.
I'm willing to accept that answer, that's okay.
Good. There is another way to talk about it, but I don't want to get into it.
Okay.
We sort of didn't do a few things. You guys know that this class isn't like got all of pre-calc, which is good because pre-calc is stupid dense in ideas. But yeah,
I'll just take a report.
This last one here. Does anyone notice we've done this problem already? Sort of? Okay. I didn't do this on purpose, to be honest, but here's the mistake people make. And I'm not highlighting anybody because somebody made this mistake, but it's not being. Your brain is currently trained to look for an angle that is an x and do something to it. I don't blame you. But when I have a trig function equals a number, I can figure out whatever the shit the angle is that's inside. The inside could be the cosine of x squared minus 4x plus 7x minus the natural log of x divided by it. And I can just say all that shit equals pi over 6. I don't have to work that out. I don't have to do anything about it on the first step. So this is cosine of an angle is 1/2. What could the angle be? We already did this earlier, right? Guys, remember? What could the angle be then? What is cosine 1/2? What could this angle be? It could either be,
Pi over 3.
ooh, we got dissension.
No,
Pi over 3.
It's got to be far away from the x-axis, so it's pi over 3, right? Because cosine likes x, it's small, plus or minus 2 by k. Or 3x is 5 pi over 3.
Plus or minus.
Now, why are we not done?
We haven't divided by 3.
Same thing in algebra. We haven't gone x by itself yet, right? So the first step is just, I don't give a shit what the name is. They called it 3x. All right, I'm going to solve for that. They can call it cosine of Aubrey. And then I say Aubrey equals pi over 3. Yes? Second step is, do I have the variable by itself yet? No, so I just get the variable by itself. So what do I have to do on each one of these?
I'm on 1/3 of a
Divide by 3. So what's it become? I know you might have said that a second ago, I don't care, I'm tired. What are we gonna divide by 3? I take a pi, cut it in thirds and cut it in thirds again, I cut it in nines. 2 pi over 3. And then here it's gonna be 5 pi over 9, 2 pi k over 3. Chihuahua.
If I write it 2 pi over 3k, is that wrong?
No, it's the same.
Oh, thank God. That's how.
It's like y equals x over 7 or y equals 1/7 x. They're both the same. Just the second one's easier to see what the slope is. Purple?
Huh?
Huh? Holy sh- that's Alan Costello routine. What's that? I don't know. Third base.
I'm
You guys
only
don't know
a third
that?
of a
You
pi.
guys know that?
Who's
Abbott
winning?
Costello, yeah.
Who's on second?
You should pull up,
Yeah.
you should show them that Abbott
No.
Costello.
What it should show is where they prove that 7 times 13 is 28.
That's what I was talking about.
Oh, I'm sorry.
Jeez.
No. Sorry.
You should show them that.
No. We have to do another example because I feel you guys are not appreciating this.
So this is our last material for this semester?
Yeah, this is the last new idea. Is it?
Okay.
Ever. Past today, you will not learn anything.
It's the curse.
It's the curse. It's the curse.
What?
We don't know.
I told you, it's sharping on the inside.
Oh, yeah.
That's sharp.
But why mark more generally? Why did they sharpen marking?
Well, it's probably the guy who murdered to make the mask. Like Bruce, you know.
Bruce!
Mark sounds pathetic.
Wow. I think that's why he's a man.
Step off my cursed
Alright, you
mask.
might not have looked at it, but I think he's after you now. Little Mustang, you were safe.
Little mistake.
Alright.
He's had his name 3 times.
So guys, let's do another one.
Alright.
I guess so, Jeff.
If you're making us.
Let's make it even more exciting.
Oh, why would you do this?
Even more exciting.
That's unfortunate. You want us to solve that?
So I want somebody to suggest a first step. Sorry, Maria, you're not. Sorry. God, I really suck. I suck. Whoever's gonna be my better tutor next time, I'm gonna just get used to sitting there. I can't shut up.
You find angles that equal one.
Nope.
Well,
What do you guys think you have to do first?
you can factor it out.
What's that, like, the sine negative something? Like you want to do?
Sine squared.
All right, no. How would you solve this equation here?
Take the square root of 16,
Why?
because it would isolate, it would kill the exponent.
So why do we have to kill the
Now, if I take a square root, what do I have to do?
Plus or minus.
Yes.
I still don't understand that.
Real quick. What do I square to get 16? Just tell me what number to square to get 16, Aubrey. What number do I square to get 16?
4 or -4.
That's why.
No, but then.
What do you think right here? We don't.
Here, no.
Negative one, yeah.
No, stop. When I write the screwed symbol, that means the positive root. So when we take a square root, we could mean the positive root or the negative root. That's why we put a plus or minus.
But what if I mean the positive root?
Well, then don't put the negative. But this equation has two answers, yes? 4, -4. So if you don't put plus or minus, you don't get both. All right.
But then why, if it's already written, do we assume that the person meant the positive one?
No. Oh, I see. So watch this. All right. This is how I do this, yes? That means plus square root of 16 and minus square root of 16. Now, of course, I don't normally write a plus, do I? I just write square root of 16. So when somebody says square root of 16, of course they mean the positive one.
But
If they
not
meant the
when I-
negative one, they'd have to write negative square root of 16. That's all.
But not when I say it.
What do you
Then
mean?
if I'm the one that's writing it, then I have to either mean positive.
If you take a square root, then you haven't picked which one yet.
But if the
They
problem-
both have to be there.
But if I get a math textbook problem that has a square root in it, I have to assume.
They've
it's
already
right.
chosen this. Do you agree with me these are two different answers?
Yes,
Okay, so if I see this, that is not this.
right.
So they have chosen the positive answer.
What if I write it, then. I
If
don't-
you take a square root, then both of these are valid.
Okay.
Because there are two things I squared to get 16. Here, look. Look. If I subtract 16 over, yes, and then factor, I get two answers, yes?
Yes.
So to be honest, taking a square root is a shortcut. When you take a shortcut, you're gonna have to do weird shit like this. This I do to preserve the two answers I would have gotten. That's probably the best short answer I can give.
Okay, I understand, I just don't like it.
Oh, that I can live with.
Yeah.
I mean, I do a lot of math, and some math I don't like either. You kidding me? Somebody help me with this thing. What's the square root of 1? Oh, I'm like, and then what's the square root of 2? I don't know. How do I rewrite this?
Root 2 over 2.
Yes. Do you guys see what you got to be careful about now? What quadrants could this be in?
3 and 1. Oh, yeah.
All 4, yes? Because sign, it could be positive or negative. You guys see that? So I'm in all 4 quadrants. Too bad. You guys am I with me? What is? Alright, so now we know we're in all 4 quadrants. So I forget about that for a second. When is sine rad 2 over 2?
45.
Blank over 4.
Which is also known as what?
5 over 4.
5 over 4.
5 over 4.
And I know I'm in all 4 quadrants. Do I need 4 statements though?
No.
In this specific example, I need 1 statement. How can I tell?
Because they're the same distance.
How far apart is it from pi over 4 to 3 pi over 4? I hear you, Brian. I just want everybody. So you are correct.
Oh, okay.
Pi over 2. How far is it from 3 pi over 4? 5 pi over 4. 5 over 4. So if I start, let me see if you guys, I'm really sorry if this doesn't make sense. But this is the idea. This is the idea. I only need multiple rows of shit if I can't pick up every answer. Do you all agree there's an infinite number of answers that are here?
Yeah.
There's an infinite number here. There's an infinite number here. So the first example we did, the distance here was not the same as the distance. So I couldn't catch all the answers in one statement. I had to use 2 different. Build from here, 2 pi, 2 pi, 2 pi. Build from here, 2 pi, 2 pi. Yes? Okay. Sorry. 2 pi, 2 pi. Here, I can catch every freaking answer. Starting from here, how far do I go? Pi over 2, pi over 2, pi over 2, pi over 2, or back pi over 2, pi over 2. So I'm going to take pi over 4, and I'm going to go up or down, go forward or backward, some multiple of pi over 2. Now, if you did this,
Oh, yuck.
yes, and you're not done. You'd have to take 5 pi over 4, 7 pi over. I wouldn't take points off. I would just say, that's way more writing. Yeah? But you're fine. You would get the idea. This is not the end of the world. It's just there's a little bit extra step you could take and go, I don't need all that shit. I could pick up every answer from one starting position. Okay, maybe. That is a very trippy idea that a lot of students have trouble with. And I'm just trying to see if I can get you guys to go down that road with me a little bit. But I'm okay if you write more than you have to, that's fine. Okay. Do you want a more, you want a freakier example or a more basic example? Freakier?
Basic.
I'm getting out.
Say again?
You're outvoted,
Yeah,
basic.
I know.
The basic.
Basic. Okay.
We're going basic, it's okay.
I have no idea what number. Okay. Let's see. Okay, let's do.
You got it?
Yep. Pretty much never break tangent and sine and cosine. It's not going to do you any good on these, right? I understand that some of you guys don't have tangent memorized, but you have to know. All right, tell me everything that tangent could be. Could tangent have an output of 0? Tangent of 0 is 0. Could tangent have an output of 1? What else could tangent have an output of? Technically undefined. What else? Rad 3 over 3? Rad 3. Let me show you real quick. Real quick. Tangent is sine over cosine. If sine is rad 3 over 2, what's cosine? This is I love this question. Yeah, if I'm in first quadrant, if sine is rad 3 over 2, cosine is 1/2, yes? You guys cool with that?
Yeah.
2's cancel, rad 3, yes?
Okay.
If tangent, what did I just say? I could do this. Oh, if sine is 1/2 and cosine is rad 3 over 2, the 2's cancel.
Right.
I get 1 over rad 3. If I rationalize this, rad 3 over 3, yes?
Yeah.
And the way I remember this, what's on top of tangent? Sine. Tangent's big when sine is big, tangent's small when sine is small. So when is sine rad 3 over 2? That's 60 degrees, pi over 3. So when is tangent rad 3, pi over 3? Maybe. Like some of you guys are like, I'm just gonna shake my head at you, hoping you'll just keep going. Okay.
Subtracting, but like slowly.
So up here,
You're like,
tangent of an angle is rad 3.
okay, so that's.
So what could the angle be?
60.
What quadrants am I in?
1.
And 3.
Yeah.
Oh, yeah. Anyway.
And I know this is,
So if it's tangent, it's always gonna be opposite, right? You're always gonna be in opposite quadrants, or no?
unless it's squared and then you're in every, yeah, but tangent's opposite because it kind of makes sense because both sine and cosine are positive, both sine and cosine are negative. So the ratios are positive here and the ratios are negative here. And that's really, this is positive, I'm here. If it's negative, I'm here for tangent. So yes, short answer is yes.
Most of the time,
Unless it's
right?
a full blue moon. Okay, so we said this was pi over 3. So what's this? Too far. You've gone too far. 4 pi over 3.
No.
Oh, yeah.
Just a third of a pi past the full pi.
Yeah.
What's that big sign?
So 4x equals pi over 3. Do I need plus or minus 2? No, yeah, 2. Do I need another statement? How far apart are these two? Pi. And then the pi.
Just need the one statement.
Okay. So this will be And again,
Is
you
tangent-
expect that because tangents period is pi.
So is tangent usually with these questions just pi, k? Like,
Yeah, most of the time tangent's gonna be plus or minus pi k. Most of the time sine and cosine will be plus or minus pi k. Kick ass. What if I give you secant, cosecant, or cotangent?
I give up.
I'll show you.
Suffer.
I'll show you.
Didn't you have to divide by 4 there too?
I'll show you. Oh yeah, here. Last step. Sorry. Sorry. Divide everything by 4. Pi over 12. Please tell me you guys are cool by this.
Yeah.
I mean, I got Calc 3 students who don't understand what it. If I cut something in thirds and cut it in fourths, I cut it in 12ths.
Yeah.
So if I divide and divide again, I've divided by a lot.
It's like you multiply the denominator.
Yeah, so pi over 3 divided by 4 is pi over 3 times 1/4 is pi over 12. But it's just easier to go, well, they all just like cut it in more pieces. Whoop-de-doo. Okay. Somebody just said something, and I wanted to do a problem related to, oh yeah, that's right. I'm the one who said it.
Somebody.
If I said secant x equals 2, you can immediately say, see your problem, Jeff, and I don't like it. I'm going to rewrite it. What is 1 over secant? So if I write this, what did I just do to this side? Flipped it! If I do something to one side, yeah, and then, so there you go. There is no secant, cosecant, or cotangent equation problems, because you can immediately make it into a cosine, sine, or tangent problem, yes? Just flip the damn things. Thank you, gods. Thanks, Mark. Read the description of this video, by the way. Yeah.
Oh my
From
god.
last night, yeah. That's when some random person on the internet go, what the hell are these people doing? Okay. And of course, that's the problem we did earlier, yes? We've done that many times, so I'm not gonna do it. Alright, I think, is there anything else? Oh, here's the last level of thing. And then I'm gonna give you guys the practice final.
That's what I was looking for. I was like, wait.
Alright, let me just jump right
I
into
just
this.
wanted to make sure mine was right.
You can do it, Jeff.
You said you could.
Let me think. Oh. Make it over here. Thank you. There it is. Okay. Ooh, you guys are so excited. You're like, all right, Jeff, listen. It's trippy, but it's not trippy enough. Can you fold in a whole different idea in the middle of all this? Yes, I can. This problem, can I just take a square root? Do you see how that side is squared? Do you see if I take a square root, doesn't everything just mess way the shit up? I don't want to do that now. Any suggestions besides cross it out and go home? Because I won't accept that.
I'm out of luck.
Let me write this a different way. You ready? So you all agree with me that sine is a stupid thing for a function? Alright. I'm going to call sine s for a minute. If I just call sine x s, why am I allowed to do that? Because I don't know what sine x is. I'm allowed to give it a variable then. I'm going to call it s. Do you guys see what to do with that? What can you do? Yes? You can do what to it?
Factor out of that.
Factor. No, you can't factor an s out because the last dude's a -1, ain't got an s in it.
Just factor the whole thing. Factor out of 1.
Plus 1 and then.
Factor out of 1 don't do shit for me.
It's just like, yeah.
2s squared.
It's like.
So the numbers aren't too freaky, so I'm not going to do all this shit. We should be able to reason this out.
It's
2s squared, what's got to be here and here?
S plus,
2s and, come on, 2s squared. 2s? S. Is there any other way to do it that I even want to consider?
No.
No. You can put 2 over there, but that's not really different. What's got to be here? Don't worry about the sign. 1 and 1, yes?
Yeah.
So now it's just freaking try the signs until it's right. Plus. Which one is plus?
Like the second one.
Do you see how the 2 comes from here?
The second one is
That's gotta be positive, that's gonna be negative, so the middle turns out positive, yes? So I replaced a more complicated thing with a single variable for a moment to make it easier to look at. Yes? If I solve for S, what is S? What did I replace with S?
What? What did you?
Yes, who cares? S could be negative.
Sine?
What is S?
Sine X?
Sine X, good. So if I solve, so,
So
Well,
you
no,
just,
because that doesn't match the,
wait, what? What do you?
the way you've written it, wouldn't it be, it would, if you multiplied it back together, it would be 2s squared minus s minus 1.
no, be minus S plus 2S plus S.
Ah.
So I made the thing that came out with a 2 positive, so that it would end up plus, yeah. That, okay, I see. I thought you were talking about this is gonna give me a negative 1S, okay. Are you guys cool with that being S equals 1/2? S equals negative 1? But what's S?
Sine.
Then I have two little equations, don't I? This one's easy. Let's say I want the answers from 0 to 2 pi, just to. When is sine negative 1? Which is what?
Oh god.
0 pi over 2, 1 pi over 2, 2 pi over 2.
2 pi over 2.
When is sine 1/2? What quadrants?
Just pi over 6.
1 and 2 is when y is positive, yes?
Yeah.
What's the reference angle? Pi over 6. This is not right, 2 over 2. So x is pi over 6 plus or minus 2 pi k, or x is 5 pi over 6 plus or minus 2 pi k. So I get 3 answers. Yeah. So here, I'm gonna give you guys the practice final, just because I don't want to forget to. Maria's gonna give some of you guys, she's gonna give everybody else.
She gets the big job.
We're just gonna take one from
I got one.
Maria. What? Oh, that's right, earlier you got, yeah, that's right, they came by the office earlier. You broke Murphy's brain for a minute, she's like, I didn't give you one.
Maria, did you try to draw a mark on the board? What is that? That's Mark. Ugh.
That's smart.
You
I
didn't
think he's a
see
bit
it.
incomplete.
That's creepier, actually, than the actual one.
That is creepier. It's like tomorrow it's gonna be a little more there, like he's coming through.
Does anybody not have one?
And then
I don't have one. I'm just kidding.
Damien doesn't have one.
Man,
That's a fact.
Braden's making friends today. Alright, okay, so let's do this. What I desperately need you guys to do is.
Do you have one?
I do now. I need one. Do you have one?
Yeah.
Okay. Gotta do some homework. Okay, the minute I say this. We're done. The only thing we have to do is like practice. Yes? Monday, Tuesday next week is devoted to review. I'm not gonna give you a quiz before the final. Right? I don't wanna. Oh, okay. No, we should, okay. Well, no, you can. I was considering giving us tomorrow night off, but I think we should meet. See, the minute I said that. So we should meet, yeah, so come, please come. We're gonna do more of this, yes? Please, dear God, try some of the homework out, yes? We can even, if we get to a point where we can start looking at the practice file a little early. Maria's gonna be doing that too. That's one thing she's gonna look at is the practice file. She can make up some other problems from other stuff if you want. Okay, and that's it for today. So that is it for the semester for new stuff in terms of new stuff. Next week is our final on Wednesday. Yeah, it's crazy.
Die.
Guys.
Die. What the heck? We just started this class.
Sorry about that.
I really do hope some of you guys consider letting me know how next semester goes for you. I'll be in the Sissel.